Let's go through a simple example of centering using these matrix manipulations. So remember, we're working with the MT cars data set, and our X matrix here is the vector of ones, horsepower, and weight. So let me just define N as the number of rows of X, and then I is going to be a diagonal matrix of ones, and then H, I'm going to just define H as the right-hand part of the matrix I minus Jn, Jn transpose Jn, inverse Jn. Okay, so that's going to be, we discussed in the last lecture that that's just a matrix of ones. So that's matrix 1 with n rows and n columns, and then divided by n. Okay, so we're going to say that the centered version of the column-centered version of X is nothing other than I minus H matrix multiplied times X. Okay, and then let's now apply to our centered version of X along the columns the function mean. And these should all be about 0 if we've done it right. And of course they are, up to machine precision. By the way, if you do sweep, for example, is probably a more efficient way to do this. So if you wanted to do XC2 is sweep X to apply X to mean. So first we're going to calculate the means, and then we're going to sweep the means out of every row. Okay, and then now I want to apply XC to the mean. You'll see that it, of course, mean centered it that way as well. However, that doesn't lead, that's just the computational aspect. The matrix result is actually kind of useful for a lot of the mathematics we're going to be doing later on in the class.